And now to a problem with a distributed load. So we have this bar down here in green. It's 20 meters long, and it has this strange shape for a loading curve. Right? The loading curve is given to us as W of x is 1/2 x times 20 minus x, and that squared, Newton per meters. Now, because this is a somewhat strange shape, right, we can't just find what it is if we're a rectangle or triangle or something. We actually have to do the integration. So if we do that first for FR, right, we can say FR is equal to, and then from 0 to L, not to 4, right, if we consider this to be L, over W of x dx. So that is 0 to 20 meters of 1/2 x 20 minus x, not x squared, but bracket squared, and that dx. Now we're going to leave off the units here because that becomes a little cumbersome. All right, so if we want to write this a little easier, we can pull the 1/2 out because it's a constant. That's not a very nice looking integration sign. So 0 to 20 meters. And then we'd have x times, if we FOIL this one out, right, then we'd have 400 minus 40 times x plus x squared dx. And of course that is then, we pull in that x in the front, we would get 400x minus 40x squared plus x to the third. Oops, dx, just squeeze that in there. And that is relatively easy to integrate. So that would be 1/2. Now dividing that by 2, so we'd have 200x squared minus, well, 40 we can't divide by 3, so 40 over 3x to the third plus 1 over 4x to the 4, from 0 to 20 meters. So if we plug that in, we get 1/2 times 200 times 20 squared, we'll leave the units off, minus 40 over 3 times 20 to the third power plus 1 over 4 times 20 to the fourth power. If we do that, plug all that in, then we will get 20,000 divided by 3 Newton, or 6,666.7 Newton. Right, so that would be the resulting force. Right? So if I take all the force that's acting down this bar and represent it by one concentrated force, then I would get 6,666.7 Newton. Now I also need to find the location, and let's remember that the location is just kind of what we call x tilde, right? Was the mr over fr. Fr we already have, which means now we're up to doing mr. So mr was very similar. Again, an integral 0 to L. We keep on trying to do x, f4. And then instead of just wx, it is now x times wx dx. So that means that would be integral from 0 to 20 meters times x times that whole thing there, 1/2 x 20 minus x there squared. Make sure I have the right location. dx, that again we can pull the 1/2 out. Integral 0 to 20, I'll leave off the meters. Then we would have x squared. Again, we can FOIL this out. That'd be 400 minus 40x plus x squared dx is equal to 1/2 0 to 20 of 400x squared minus 40x to the third, right? Just multiplying the x squared into there, plus x to the fourth dx, and that is 1/2. Now divided by 3, so that'll be 400 divided by 3x to the third minus 10x to the fourth. Looks like a 9 fourth. And then plus 1/5 x to the fifth. And from 0 to 20. Well, the 0 we don't have to worry about. There's no constants in there. So that would be equal to 1/2 times 400 over 3, 20 to the third power, minus 10 times 20 to the fourth power, plus 1/5, 20 to the fifth power. And that gives me 160,000 divided by 3 Newton meters, which is equal to 53,333.3 Newton meters. All right, so we're not interested in the moment itself. We're only interested in dividing it by the force. So we can say x not tilde, x bar is equal to mr over fr. Mr we have here, use the exact one, over 3 Newton meter. Right? If we use the exact one, then we don't do any rounding errors. And then 20,000 over 3. Divided by 20,000 over 3 Newton. The newtons cancel out, leaves me a meter. That's exactly what I have. The divided by 3 cancels out, so I have 160,000 over 20,000, which is the same as 16 over 2 meters, 8 meters. All right, so we can say, based on our calculations, that we're going to get this for 10, so maybe somewhere here we'd have FR equal to, what do you say, 667.7 Newton, and this will be a distance of 8 meters. So with that, we've taken the distributed load and we formed it into a concentrated load, and we gave it the right location, so the moments all balance out.